Alright guys, let's take a look at this, yeah? I didn't mean to trick you with this or anything, it's just that relates to this. So the first couple problems are just looking at the form and why they work the way they do. So 1x plus 2x plus 3x is remarkably 6x. So 1 rad 5 plus 2 rad 5s is 3 rad 5s is 6 rad 5s. Does everybody see how those are the same problem? Just in part B, I'm like, oh, let x be square root of 5. So it's going to work exactly the same way. So 2 is another problem like that. 4x minus x. Be very careful. If you wanted the x to cancel, you couldn't use subtraction. You'd have to use division. Right? When I subtract or add, the coefficients change. When I multiply or divide, then the parts can change or go away. Does that make sense? Some of you guys would thought the answer would be 4 or something. No. So 4 rad 6 minus 1 rad 6 is 3 rad 6. All right, sweet. So like terms doesn't care what the things look like. Right? They just have to. What I mean by that is it doesn't matter if they're fractions or radicals or variables. They have to just be exactly the same. And then you can collect them. So number 3 drove some of you guys a little crazy, but I have to put that down here just to make you realize that in the real world, not everything's freaking like terms. I got 3 of these plus 5 of those. I'm done. There ain't nothing I can do with that. Now the difference between that problem and this problem is that there's more stuff in here I can work with. Here I've only got a 7 and a 2. Can't do anything with that. Here I can break 8 up, I can break 18 up, I can do something with it. That's the difference. So these don't start off as like terms, but I can make them like terms. What about this guy real quick? What am I like terms? The rad 5s and the rad 7s. So 1 of these minus 4 of these is negative 3 of these. 3 of those minus 5 of those minus 2 of those, and you're done. I know some of the guys feel like, no, I want one thing. It's got to be making. No, I'm sorry, I just can't. It's like me saying, what's x plus 2y plus x? What's x plus 2y plus x? 2x plus 2y. Can you make that 4 or something? No, you just screw. Yeah, all right, that's it. There's just 2 things I don't know. Shit. X and y. So here, I don't know which way you like to do it, but
4 and 2.
All right. I really want to make sure you guys see why this is. I'm going to do this both ways. This way, square root of 8 is the square root of 4 times the square root of 2. Square root of 18 is the square root of 9 times the square root of 2. That's what they are. Is that cool?
Yeah.
That's just true. But the square root of 4 is?
2.
So why write the square root of 1? I'm going to write 2. Shit. Square root of 9 is?
3.
So 2 of these plus 3 of these? Alright, so what's that look like the other way? I don't know. So here, if I do it the other way, this is 2 times 2 times 2. This is 3 times 3 times 2. And some of you guys realize what I was saying earlier. This way I get people, and I'm not picking on anybody, somebody did this, but do you see, somebody put this, and a lot of people do that, so I'm not picking on anybody. Do you see what this person did wrong? They're in the wrong places, right? How can the 2 come out when there's only one of them? What is the square root looking for? 2. Groups of 2. So here, you can't go wrong with this guy. 2 is out, and this poor little 2 is left. Here, the 3 is out, and this poor little 2 is left. That's why I prefer this way, because I can see exactly where everything's coming from. Here, there's a little bit of, well, which number goes where. It shouldn't be that way. Whoever there's not enough of is left inside, if you do it this way. All right. So here I get the same answer, 5 right 2. Oh my gosh. Sorry, it's just really annoying. I'm sure you guys are like, yes, we know that, Jeff. Alright. So this way, 5 and 6 work the same way. Just got a big kick out of that. So again, let me just do it the way that I slightly prefer. 12, 4 times 3. Now watch. Now I really want this to make sense. There's a 4 right there, right? Write the 4. I just rewrote the square root of 12 as the square root of 4 times the square root of 3. Does everybody see how that is the same as that?
Yeah.
If you write it like this, you can see where everything comes from. What's the operation? Everything's multiplying. So, let's worry about this guy in a minute. Let's finish this guy out. There's a 4. Square root of 4 is? 2. And there's a square root of 3. So there's 8 square root of 3's. Now what can I do with 75?
25 3.
I like it. So I got the square root of 25, square root of 3. Square root of 25 is 5. So how many root 3's do I have? 3 root 3's. Alright. That's right. Excellent. So here, this gave us a little bit of trouble too. Why am I allowed to write a 5 underneath this?
Because 25 times X.
Because 25 has 2 5's in it, right? Or square root of 25 is 5. But why can I not then write an X? Why can I not write this as 5X? Because I only got one X in there. The square root of X is not X. So what's really going on here is this is the square root of 25 times the square root of X. This is the square root of 36 times the square root of X. Square root of 25 I can do. Square root of X I can't do. Square root of 36 I can do. Square root of X I can't do. But now, I got 11 right X's. So you can only rewrite something out of a radical if there's enough of that thing in there. Does that make sense? Square root of 25 is 5 because 25 has 2 5's in it. But the X can't escape the radical. There's only one of them. Right? To break that wall, you need at least 2 guys. Cube root is a little bit stronger wall. You need 3 guys. Oh shit! I don't know. Does that work? There's a whole teaching method there, but oh well. People escaping prison. All right. So here now it's the same idea. It's just cube roots. Yes, sir.
I got 11x with 1/2 power.
Sure, I love it because what is the square root of x? X is the 1/2.
Oh.
I like it. So those are the same answer. Kick ass. So there's no real reason to make them fractional exponents, but you totally can. Because it's the same thing as the square root. I like it. So what happens here? How can I break 16 up since it's a cube root?
8.
Good. Cube root of 8 times the cube root of 2. This is a hint. 2 goes into 54. So the cube root of 27, cube root of 2. Cube root of 8 is 2. Cube root of 27 is 3. So I get 2 cube root of 2 plus 9 cube root of 2 is 11 cube roots of 2. So all we're ever doing is instead of saying cube root of 27, I'm going to write 3. Because that's what it is. I mean, that's really all you're ever doing when you're simplifying expressions or numbers. You're simplifying stuff. All right. So what do you get here? Now, I really want this to make sense. Of course you do, Jeff. But real quick, let me write, if I had 3x times 5y minus, well, I guess that'll work, minus, screw it, Jeff. 3x times 5x squared minus x. Let me just say that. How would you do this? 15 x cubed. So you multiply the coefficients and then you multiply the unknowns. Minus, again, 3 times 1 is 3. X times x, x squared. So you multiply the coefficients and then next to them you multiply the unknowns. So the same thing happens with radicals. When I multiply these, I can do 3 times 5. Oh, sorry. So 3 times 5 is 15. What's square root of 5 times square root of 2? Now, I didn't see anybody do this, but does everybody see how that's one term? Right? One term times one term is one term. And sometimes I get people tell me it's 15 plus rad 10. I didn't see that anywhere, so that's good. So that times that is this term. That times this will become 3 square root of 35. Now, I understand that part of you wants to go further. You're like, that can't be it. There's only one thing. But you're done. Why? How do I know I'm done? Are these like terms? No. 10 has got only 1 5 and 1 2. 35 has only got 1 5 and 1 7. So nothing can be done. So I'm done. So sometimes there will be one step. Let that happen. Okay. What about this? What's square root of x times square root of x? X. Square root of x squared, which is x. I like it. Then you get plus square root of 5x minus square root of 5x. Square root of 25 is 5. What happens here? So I get. Do you see how this is a difference of squares kind of deal? You can see that?
Yeah.
Not what we're used to. What's x squared minus 9? How do you do that? That's right. Square root of x squared minus square root of 9. Square root of x squared plus the square root of 9. Why, Jeff? X minus 3, x plus 3. Where did 3 come from? Cut 9 in half. Isn't that what square roots do? I know I'm going a little further than normal. Some of you guys are like, do we have to start writing that? No, please, dear God. But this is just showing you, in your face, what you do. You break them both in half. Well, what breaks things in half? Square roots, right? So if I wanted to factor this, you can. Totally. How do you break x in half? Well, square root of x, square root of x. Minus plus, square root of 5, square root of 5. Isn't that what we just proved? Didn't I say start here and then you did it and you got this? So the idea of factoring goes beyond whole numbers. But when we learn factoring, we're like, let's stick with whole numbers. And then later we start to go, oh shit, we can do stuff like that.
And that's why x to the 1/2 power is the same thing as the square root of x.
Oh, okay, yes. That's one way to look at it because it cuts it in half multiplicatively. Exactly.
That's why that works.
Exactly. Alright. So this last guy is not too bad, right? Just a few more things to do.
15 square root of 4.
Alright, sure, I'll write it out. 15 square root of 4.
Plus 21 square root of 6.
Plus 21 square root of 6.
Minus
20 square root of 10.
Minus 28 square root of
minus 28 square root of 15. Now, each one of these, none of them are reducible except, yeah, square root of 4 is times 15. 30 plus 21 rad 6, minus 20 rad 10, minus 28 rad 15, and you're done. Because none of them are like terms, and none of them can be reduced, so you're done. Bless you.
Okay, wait.
Yes, ma'am.
Okay, so I was with you before you started adding that stuff.
Alright, let me do that again. Let me give myself some more room. Alright. So we do this times this. Bless you.
Got all that.
15 square root of 4. And then I get 21 square root of 6. Minus 20 square root of 10. So you're all cool with this? Alright. The only thing I did was the only thing I can do. Square root of 4.
That's a 2.
Yeah, so that's 15 times 2, which is 30. And then everything else is still there. That's it.
Oh, okay. Oh,
Maybe it's just because I didn't have much room.
okay.
But yeah, that's all I can do. It feels not satisfying, but oh well. Right? I mean, there's no like terms. There's not shit I can do. Real quick, do this for me. What's x plus 2y times z minus 5w? We're all able to do this, not a big deal, right? xz minus 5wx, right?
Wait, what?
What's that? Just foiling, right? X times z, xz.
I do the raw.
X times 5w, 5wx. 2y times z is 2y z. 2y times negative 5w is any like terms? You're done. See, I mean, it's the same idea. It's just because there just happens to not be like terms. Oh well. I like it. I like it. All right. What is today? Today is Tuesday. All right. And let me check one thing now. I'm thinking about this right. So I had the little homework sheet with them. I gave all mine away.
It's right here.
Alright. Cool. Okay. Just want to keep myself on track. So, let's take a break, huh? Come back at 5 after.